Hey everybody, welcome to another lesson on the GED book 2019. Okay, so today we are doing the fractions and operations. This actually had another part in the beginning, which is the last lesson. But I'm basically splitting them up a little because there's a lot of content in each. So I just wanted to show you the first page here. This basically explains everything you need to know for the page that we are going to do. Since we are going to do it and I'm going to be walking you through it, I'm not going to go through all of this with you. We'll just learn it as we do the lesson. But if you need to refer to this, you can always come back and pause it and read over this. I will read the key ideas though. It says you can add or subtract fractions, but they must have the same denominator. If denominators are not the same, find a common denominator and raise one or both fractions. So just add something to that. So a common denominator is the denominator's the trying to get this to be a regular cursor here. The denominator is, see the 10 there? Or say add 3 over 10 plus 3 plus 5 over 10, so the denominators are both the same, 10 and 10. Whereas this one, for example, could be a 5 or some other number. That would be a common denominator that's not the same. Okay. So yeah. So last one here. Always reduce answers to lowest terms and change improper fractions to mixed numbers. Okay. So this is a mixed number here. 4 and 1 over 16. Okay. So improper fraction, for example, is, see how there's 3 over 10 right here? If that was, for example, 12 over 10, that would be an improper fraction. Anytime the top number is higher than the bottom number, that's an improper fraction. And improper fractions you can change to mixed numbers, because that if it's improper fraction, it indicates there's at least one whole number in there, and then possibly a few left over. If it's like, if it was 10 over 10, that would be one whole number. If it was anything over 10 over 10, it would be a whole number and some extra. So you'll kind of get what that means as we go through this lesson. Anyways, here we go. Okay, so let me just expand this a tad bit. Okay, so we have solve. Reduce answers. Also, it's very important to read what it actually wants you to do and make sure you understand, because even as I was doing this, it kind of reminded me of that, because I was like not reducing to the lowest term, for example. So if the GED does tell you to do that, then and you don't do it, then most likely you'll get that answer wrong. So solve wants us to solve it. Also wants us to reduce answers to the lowest terms. Okay. Then simplify improper fractions as mixed numbers. We're going to go through that. So in case you're not 100% sure, just stick with it. Stick with the lesson. Okay, so let's do number 1. I'm not going to do all of these. I kind of pre-selected some that are different. So they're not, that are different from the ones that we're actually going to do. Like from each other is what I mean. So that we get a little bit of a variety, but doing all these would probably take a little bit of time. Especially since I'm writing on this little notepad here with a mouse. Okay, so let's find, okay, so these have like denominators here, okay. That is 3/8 plus 1/8. So 3/8 plus 1/8. So easy, since these are like denominators, 8 and 8, we don't really have to do anything other than add. So we add 3, we add the numerators. 3 plus 1 is 4, and we keep denominators the same, 4/8. Okay, now, like it said here, we have to reduce answers to lowest terms. So find the highest number that both of these can go into. Okay. Let's see. That number would be. Uh, oh, I already know in my head what it will be reduced to. Just trying to figure it out here. It would actually be 1/4. I'm just trying to see how to explain it to you guys to do that. I said find the highest number. I actually meant the least number. So, well, the highest number that goes into both of these. So, for example, 4 goes into, does 4 go into 8? Yes, it does. And it also goes into itself. Okay? So you go 4 goes into 4 one time. Okay? And then you go 4 goes into 8 two times. So we've pretty much reduced it. Okay, you know that you've reduced it when to its lowest terms when what do you call it? The only number that can go into both of these is 1. Okay, for example, let's see, 1. Okay, we won't start with 1, but yeah, obviously nothing else can go into 1 in this example because this is 1. So anytime the 4, for example, or the numerator is half of the denominator, exactly half, then we will know that this can be reduced to half like this, okay? Because that's what it means. You need eight pieces to make this whole, and we have 4 pieces, so we have half of the whole. Therefore, half. Excuse me. Okay, so moving on to the next one. Okay, the next one we're going to do is number 5 here. So 1/4 plus 2/3. So let's see, we're adding here. Okay, so this, see how these have unlike denominators? We have a 3 here and we have a 4. So we have to make these both into, I'll just write it. You should be able to do this in your head, but I'm just going to write this here anyhow. Okay, so, and one thing that's really important, guys, is if you don't know your multiplication table, like have them memorized at least up to 12, then you should definitely do that because these type of problems here, the speed in which you do them are highly dependent on how well you know the multiplication table. Like I can look at this and know what they both, what common denominator I would change these into, just because I know that 3 times 4, and it's just coincidence that I'm saying 4, but like both of these can go into 12. That's the first number they can go into. That would be similar for both of them, okay? that both of them can go into. So I know 3 can go into 12 4 times because I know my times tables. Okay, so I go 3 times 4. Okay, and 3 times 4 equals 12. Let's see, 12. And since we multiplied this by 4, number 3 by 4, then we have to see which one here, how many times we have to multiply this denominator. Even though you see it on top, I just took the denominators from both of these. So they're still denominators, okay? Oopsie daisy. So how many times? So we know 12 is the least common denominator. Okay, we have to find out 4 here. Okay, 4. So we need 12 for both of them. How many times does 4 go into 12? Well, 3 times 4 is 12. So, okay. So, the reason that you need to know these numbers here is because when you change these, okay, for example, 3, this now becomes 12, okay? And so does this, instead of 4. And cross out these numbers because they're now 12. And we know that it took 3 4 times to get to 12, so we need to multiply this numerator by 4 as well, because we have to. Anytime we change the number of a fraction, it changes a fraction, and both of these have to be changed in equal proportion. So if we change this 3 4 times, then we also have to change the 2 4 times. Okay, so 2 times 4 is 8. Okay, so this was 2/3 to begin with. This number here is still 2/3. If we would have left the 2 here instead of the 8, brought the 2 over like this, it would have been a different number. Okay, so let's see. And this one here took 3 times to get to 12. So this one we also have to times by 3. 1 times 3 is 3. Okay, so now we have the new number here that we are going to be using. Again, since I'm writing everything out, seems like a really long process, and it's good to know how to write it out, but if you can do this in your head, so much quicker. Okay, so that was addition, right? So 8 plus 3 is 11, and since these are the same, we just bring down the 12, okay? And your answer is 11 over 12 for number 5. Next one we are going to do is number 9. Let's erase this first. Okay, so number 9, 2 1/5. And 1 2/3. So this is an addition problem as well. Okay. So, again, see these denominators? They are not the same. So, let's see. You can usually start by, well, it's really the only way to start, but you can start by doubling the largest denominator, okay? And see, let's see, and see how many times see if the this denominator here will go into that. So for example, the doubling 5 would be 10, because the reason I'm saying is because if you double it, that is something that 5 can go into. 5 goes into 5 once, but if we double it to a 10, for example, we know 5 can also go into 10. Okay, 5 goes into 10 2 times. So the reason we do that is because you'll just get there quicker. If you, excuse me, you'll get to a denominator that will suit both of these quicker if you use the larger number. So if you use the 3, then you have to multiply it many more times, okay? So let's see, if we have to think, okay, if double of 5 is 10, does 3 go into 10? Not really. 3 times 3 is 9, okay? So, well, 3 times 2 is 6, 3 times 3 is 9, and now if we go past that, it has to go into 10 evenly. If we go past 3 times 3, then it would be 3 times 4, which is 12, so that won't work. So let's triple this denominator here, will make it 15. Does 3 go into 15? Well, let's see. Again, if you know your times tables, you can just see this right away. But working our way up, 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 3 times 5 is 15. Okay, so we have found a number here that suits both of them. Okay, which is 15 is the new common denominator. Hip hip hooray. So because 3 times 5 equals 15, remember we also have to times 5 the numerator. So 2 times 5 is 10. Okay, so this keeps the proportion of this and this the same. And this 5 we times by 3, so we also have to times the 1 by the same number, 3. 3 times 1 is 3. So now we have common denominators, okay? So we can add these. 10 plus 3 is 13. Then we just bring down the 15 because we don't need to add that. 2 plus 1 is 3. So that is our new number right there. Okay. Next we are going to do number 7. Okay. I kind of skipped over 7, went to 9 because I was doing addition first. So 9 over 10 minus 3 over 5. Put our minus symbol here. So again, we have unlike denominators here. So start by doubling the largest one. 10 yeah, 10 times 2 is 20. Some of these actually, because this is a 5 here, we know that 5 will actually go into 10. So we can just double this one here. Okay? So that's why I was saying in the first page, number or change both denominators or just one. Because if 5 can go into 10 evenly, then we can just change this one here to a 10. Okay? So, and that's with any of them. If this was 15, we could also just change this denominator because 5 goes into 15 3 times. So what we'll do is change this to a 10. Okay, so to get to 10 we had to double this, so 2 times 5 is 10. Okay, and so therefore we have to double the 3. 2 times 3 is 6, so that we keep the same proportion. Okay. Now here is our new number. So 9 minus 6 is 3. Bring down the 10. And there we have it. I'm going to check something real quick here. Okay, so I was just trying to see which one. I didn't write the one that I needed to do next down. Okay, so next one is number 8, which is another subtraction one. And just by the way, guys, we didn't go into reducing that. Let's see, 3 over 10. We didn't go into reducing that because there's no number that goes into both of these. If this was a 9, however, and not a 10, then we know that 3 does go into 9. Okay, so we go 3 goes into 9 3 times, so we reduce that to 3. Now we turn this into a 1. Okay. Okay, so number, I believe it did, yep, number 8. So 7 over 9 minus 1 over 2, which is a half. So let's see. Need to change these unlike denominators into common denominators. Okay, so we have number 9 here. Remember, we double the largest number, so if we 2 times, we know, first of all, does 2 go into 9? Not really, because 2, 4, 6, 8, 10, counting by 2s skips right over 9, okay? So we have to double the largest number. 9 times 2 is 18. Okay, before writing that down, you could see if 2 goes into 18. Does 2 go into 18? Well, it is an even number, so most likely it does. Let's see. If 2 times 9 is 18, see how we did that? 9 2 times is 18. Then we know that 2 goes into 18 as well, 9 times. Okay, so 18 is our new number. So 2, because we multiplied 2 9 times, we also have to multiply 1 9 times. So make that a 9. Since we multiplied this 2 times, 9 2 times, we have to multiply 7 2 times. 14. So 14 minus 9 equals 5. Then we just bring the 18 down. Okay. Does 5 go into 18? It does not. Okay. Any other numbers go into 18 and 5? Not really. Basically, you can see if any number up to 5 goes into 18. 1 goes into 18 and 5, yes they do, but when there's only that number that goes into them, it's already at the lowest term. So does 2 go into 18 and 5? Well, 2 doesn't go into 5. Does 3 go into? No, 3 doesn't go into 5. Okay. Does 4 go into 5? No, it doesn't. And when you're thinking, does it go into this number, you can think of multiplying that number. For example, does 2 go into 5? Well, 2 times 2 is 4. 2 times 3 is 6, so it skips right over the 5. Does 3 go into 5? Well, 3 doesn't go into 5 evenly. Then 3 times 2 is 6, so we've already jumped over the 5, so that wouldn't work. So we know that 4 would be even higher. And, like 4 times 2 is 8, so that doesn't work. And 4 doesn't go into there evenly either. So this is reduced to its lowest terms. Okay. Next question is number 10 here. Okay, so 4.5 minus 2 and 3/4. Okay, so again, see these denominators? They have to be the same. So the lower one does go into the higher one evenly. So we can just keep this 3/4 here, but this one will have to change. 2 goes into 4 2 times. Put a 4 here. Since we know we 2 times that, we also have 2 times the 1. So 2 times 1 is 2. Okay, so this will be our new number. Um, and since this is subtraction, guys, what we have to do here is we can't take 3 away from 2. So what we're going to have to do, and this is the same for all mixed numbers, even though we only have one example here, just want to let you know it's the same for all of them. You would borrow from the 4 here, okay? And we know that this 4 equals, not this 4, but each one in this 4. So like 1, okay, yeah, each one in this 4 would equal, and this is just coincidence, but it would one of these numbers would equal this amount here, because this is telling you how much it takes to equal one whole number. Again, if this was 6, this here would still indicate, like, there's 4 here. Each one of these 4 would equal 6 if this was a 6. Okay, so this just kind of coincidence that it's 4. Okay, but yeah, anyways, so for example, we're going to borrow 1 4 here. We're going to make this a 3. Okay, so we know that the one that we're borrowing equals 4. So we will add 4 to the 2. Okay, let me just erase this. 4 to the 2. Well, actually, I'm going to keep it there so we know. And then that becomes a 6. Okay, so now we can do this problem. 6 minus 3 equals 3. And we keep the 4's the same. Now 3 minus 2 is 1. So now we have our answer, 1 3/4. Okay. Alrighty then. These down here are essentially the same. As you can see, number 11, 12, 13, 14, they're essentially the same, just they're not arranged into columns like this. Okay. But we'll go ahead and do a few of them as well. So, ones I wrote out, we'll start with number 11. We're actually going to do 4 of these ones. Number 11 is first one. Let me erase this first. So, 5 and 2 over, 5 and 5 over 6. Let's see. Otherwise known as 5 and 5/6. and 2. Okay, so we are adding this. Always make sure you look at the symbol of what you're supposed to be doing as far as adding, subtracting, multiplication, etc. So, let's see. We need to make these like denominators. So 3 can go into 6 2 times. Okay, so let's put the 6 here. Now we need to times this by 2 as well. So that becomes a 4. Okay, and this stays the same here because now they're both 6. So let's do this, cross this out so you don't get confused. 5 plus 4 is 9. So we have 9 over 6. Then we have 5 plus 2 is 7. Okay. Now you'll notice something different here that we have not encountered. This is well, it's not only a mixed number because it has, the whole numbers here, but it's also an improper fraction because the numerator is larger than the denominator. So we need to reduce that. So anytime that you have this larger, I explained this earlier, than this, we know we have at least one whole number. Okay? So in this case, it takes 6 to make one whole number, so we know we have at least 6 here. How many do we have more than 6? We have 6, 7, 8, 9. Okay, so we have 3 more than 6, which is 7, 8, 9. So we can just write 3 here to remind us. Okay, so we know now that we can change this to an 8. Okay, because we already have 6 over 6 and some extra, which makes another whole. Okay, so we can change this to an 8. And we had 3 left over from the 9. Okay, so we'll remove the 9 and we'll put a 3 there. Okay, so, and then we have to see, now that that's done, can we still reduce this even further? Well, remember I told you anytime the numerator is exactly half of the denominator, we know that this number is a half because this equals one whole number, one of these guys over here, and this is half of the whole. So we know that there's half of the pieces to make this whole over here. So we can reduce it. This becomes a 1, and this becomes a 6. Okay? Sorry. Becomes 1, this becomes a 2, which equals half. So that would be your answer right there, your reduced answer, 8.5. Erase this. Okay, next one we're going to work on is 15. Here we go. 3 1/3 plus 5 2/3 plus 3 5/6. Don't get intimidated by this extra number here. You pretty much do the same thing. Yes, it will take a little longer, but the concept is the same. Okay, so again, are all these, the first thing you always do, are all of the denominators the same? No, they're not. But we're lucky because we do know that 3 goes into 6 two times. So we can leave this here the same. Then we go, okay, 3 does resolve into 6, so we can add 6 there. How many times did it take for this 3 to get 6? 2 times. So then we have to multiply the numerator by 2. So 2 times 2 is 4. 3, well, 3 goes in 6 also 2 times, so 2 times 1 is 2. Okay, I'm just going to write this here again. Just keep it a little organized. Alright, and we know that this is addition. Okay, so let's add all of these. 2 plus 4 is 6, plus 5 is 11. And we keep the denominator, which is 6, okay? Then we add these up. Okay, look at just like the last one, we know that we have an extra one in here, okay? Since this is above 6, we have, let me just write this here. Essentially we have 1, okay, and how many left over? Well, we needed 6 up here to make 1, like this, okay? So above 6, how many do we have? We have 7, 8, 9, 10, 11. So we have 5 extra, okay? So if this was the number in itself there, we would just go 5 over 6, okay? So the reason I wrote that down for you guys like that is because when we're adding this here, we'll have to add the 1 to it, okay? And this just makes it easy for us to know that there's one extra whole number. So 3 plus 5 plus, well, 8 plus another 3 is 11. But we also have another one here that came from this number here, so 12. Okay, so we are going to put 12 there. And we know that after we had done this here, that there was 5 left over, so we'll change this to a 5. Okay. Otherwise, if we didn't do that whole process, it would look like this. 11 and 11 over 6. And that's not a resolved answer. It is, but it's not simplified, okay? Or resolved to the lowest terms. Then we can still check here to see if this is the lowest terms. Is there any number that other than 1 that goes into both of these numbers? No, there isn't. So we know that this is our answer here. Okay. The reason I was pointing this one to see if it's resolved was because the same as here. 5, 6. Any number that goes in 5 or 6? No, there's not. So this is your answer. Erase this here. Okay, the next one we are going to work on is 20. Okay, so we have 15 and, well, 15 minus 3 and 7/8. Okay, so we have something interesting here. All we have is a whole number here, okay, which is 15. So how can we do this subtraction problem? We actually can't. So what we'll need to do is borrow 1 from 15, okay? And what makes 1 whole? Well, we know that there's 8 pieces in this problem, okay? That makes it 1 whole. So we'll put an 8 here, and to indicate 1, we have to put another 8 here. okay, because we borrowed 1 from 15. And this, basically this in fractions means 1, okay? So we will change this to a 14. No, I'm just going to write that down so we remember where we came from. I'll just cross it out, make that a 14, okay? Alright, so now we can do the problem, which is subtraction. 8 minus 7 is 1. We bring down the denominator, which always stays the same. Now 14 minus 3 is 11. Okay, so this is your answer. Can we resolve this into anything lower? No, we cannot. This is already a 1. Okay. Okay, I actually just looked at my notes and realized 11 was one of these ones that I wanted to do as well. So, did I? Can't remember if I actually did 11. I think I did, actually. Anyways, we just did 20. So, we are going to do 22 now. 9, this subtraction problem. 9 and 11 over 12. And 8 and 5 over 8. Okay, subtraction. Let's see what we have here. We have unlike denominators. Okay, so since 8 does not go into 12 evenly, we have to find, remember, we'll double the largest number. Okay, so 2 times 12 is 24. Does 8 go into 24? Just by knowing your times tables, you should know that it does. 8 times 1 is 8, 8 times 2 is 16, 8 times 3 is 24. So, we can use 24. Okay, so to get to 24, the 24 here, we had to double this. So we had to 2 times 12, so we'll 2 times 11, which is 22. Okay, 8 goes into 24 3 times. Okay. So we will 3 times 5. And 3 times 5 is 15. Okay, so now we have a doable problem. So 22 minus 15 is 7. And this will always be, we always bring down the denominator. 9 minus 8 is 1. Now, can we resolve this any lower? Well, is there any number that goes into both of these numbers other than 1? I don't believe so. 7 does not go, like 3 times 7 is 21, 4 times 7 is 28, so we know 7 doesn't go into it. 2 does not go into both of these numbers because 2 does not go into 7, neither does 3. Yeah, there's no number that goes into both of these, so this is reduced to the lowest terms, okay? Okay, so let's move down. Okay, to make the top, well, let's read this first. Choose the one best answer to each question. So this is obviously multiple choice. To make the top of a dining room table, Craig glues a piece of oak that is 5/16 of an inch thick to a piece of pine that is 7/8 inch thick. What is the total thickness in inches of the tabletop? Okay, so we know that we have to combine the two, which means, especially if they're looking for a total thickness, which means we need to multiply, not multiply, add those two together. So same exact process as we've been doing this whole time. Okay, again, we need to make the denominators like. Can this number go into this number? Yes, it can. It goes in there 2 times, because 2 times 8 is 16. So we can keep this the same. This we need to change to 16. Since we had to times the 8 by 2, we also have times the 7 by 2. So 2 times 7 is 14. Okay, let's cross this out. Just keep organized. We know it's subtract. No, we know it's addition. So we have 14 plus 5. We know what that is. 19. And we have, well, 16 always stays the same. Okay. Can this be resolved or reduced? Yes, it can. Okay, so anytime you can reduce it, it's better to reduce it. So remember, since this number is larger than since the numerator is larger than the denominator, we know that there's at least one whole number. Now how many are left over 16? Well, let's see, 17, 18, 19. So we have 3 left over. Put that there. Put 16 here. So now that we've changed this to a mixed number, can this be reduced at all? Well, 3 does not go into 16. And any other numbers below 3 that go into both of them, there really are not. So we know that this is the least right here. So as you can see, your answer is B. And you can see, even though they didn't tell you to reduce it here, they still reduced it. Okay, so 1 and 3 over 16, or 3/16. Okay, let us do number 27. Okay. Carol will use the 2 bolts shown below to assemble a book cart. How much longer in inches is bolt A than bolt B? Okay, so when you're trying to find the difference between two numbers, you have to subtract. Okay, so we'll subtract the little number from the bigger number. So the bigger number is 2 and 7/8. The little number is 1 and 3/4. Is that 3? No, that's a 1. Okay. So 1 and 1/4. Okay. We need to subtract. So remember, make the denominators the same. Yes, 4 goes into 8 2 times. So we can put 8 here. Then 2 times 1 is 2. Okay, so that's our new number. So 7 minus 2 is 5. Then we bring down the denominator, which is 8. 2 minus 1 is 1. So, can this be reduced by looking at it? No, it cannot. Okay. So 1 and 5/8 is your answer. So it'd be C. 1 and 5/8. Next one, almost done here, guys. 28. Now you see why I divide these lessons up, because they're I mean, we've already been here for, I think, about half an hour, so still not done yet. So 28. At a fabric store, Melissa sold 8 7/8 yard of cloth to a customer. If the material was cut from a bolt of fabric containing 23 1/4 yards, how many yards are left on the bolt? Okay, so again, we have to subtract because we're trying to find the difference. So 23 is the original size, 23 1/4, and we're subtracting, they used, well, she sold 8 7/8 to somebody. I'll actually put a 2 there, but it's 23. Okay, so again, first thing we do is find the common denominator. So does 4 go into 8? Yes, it does, 2 times. So we can use 8. Keep this as the 8. Make this the 8 too. And we know that 4 goes into 8 2 times. So we also have to multiply the numerator by 2. Okay, so this is our new number here. So, okay, as we can see, we cannot we cannot take 7 away from 2. So we have to borrow from 23. Okay, so we'll cross this out, make it a 22, and we know that one of these whole numbers equals 8. Okay, because this defines this the whole number as we specified earlier. So we have just, from borrowing 1 here, we've just added 8 to this number. Okay, so 8 plus 2 is 10. We'll just cross this out, make it a 10. So now we can subtract 7 from 10. Okay, so 10 minus 7 is 3. Bring down the denominator. Now we subtract this. 22 minus 8 is 14. Then we always look, can this be reduced? By looking at it, I can tell it cannot. 3 does not go into 8. And 2 does not go into 8 evenly either. So 1 is the only number. So 14 and 3/8. So A is your answer. Okay. Okay, so a batch of salad dressing requires 1 2/3 cups of olive oil, half a cup of vinegar, and 3/4 cup of water. How many cups of salad dressing will the recipe produce? So we need to see, we know that we need to add all of those up to find the total. Okay, 1 2/3. Plus half a cup plus 3/4. Okay, so we need to find a common denominator, number that each of these goes into. So take the biggest number, double it. We're gonna make this an 8, and let's see. So does 2 go into 8? 2 goes into 8, but 3 does not. So that number will not work. So triple it. 3 times 4 is 12. Does 2 go into 12? Yes, it does. 6 times. Does 3 go into 12? Yes, it does. 4 times. So we know that 12 is a common denominator that we can use. Thank you, 12, for being there for us. Okay, so to get to 12 here, we had to multiply 4 by 3, so 3 times 3 is 9. Here we had to multiply by 6, so 6 times 1 is 6. And here by 4, so 4 times 2 is 8. So we need to add these. 8 plus, I like to add the higher numbers first. 8 plus 9 is 17. Plus 6, 17, 18, 19, 20, 21, 22, 23. Okay, so 23 over 12. Plus we have the 1 here, so we'll bring the 1 down. Okay, so we have to look at this. Since this is larger, the numerator is larger than the denominator, we know we have an extra whole number we can add to here. Okay, so let's make this a 2. No, I'm just going to keep that there. Okay, we'll make this a 2. And how many more is 23 than 12? You can count it. 13, 14, 15, etc. But we know it's 11. Okay, so we took that 12 out of the 23, and there was 11 left over from the 23. We added it to the whole number, since we know that to make one whole number, you need 12, since the denominator is the indicator of that. Okay, so now beyond that, can this be reduced at all? Is there any number that will go into both of these? There is not. So we know that this is reduced already to its lowest terms, and your answer will be C, 2 and 11 over 12. Anyways, thank you guys for sticking with me through this lesson. Hope you learned something. If you did appreciate it, please like and subscribe, and pay attention for the next lesson that will be coming out. Thank you very much.